understand what is momentum, let's consider two examples. One, we are discussing about situation of truck, and on the second side we are discussing about bullet. Let's consider the case of truck. Initially, let's say the truck is at rest and it is parked along the roadside. So it is not going to harm any person. It is at rest, it is still parked along the roadside. It is not going to harm any person. But let's consider the case the truck is moving with a very little velocity of 5 meter per second. Then the truck being too heavy, it is going to harm a person. It may kill a person which is coming in the path of the truck. It may kill the person. On the other side, the bullet is fired from a gun. Bullet mass is very small, let's say 20 grams, and velocity, it may reach up to 1000 meter per second. In some rifles or pistols it is 500 meter per second. In some, depending on the type of pistol or revolver, it may go up to 1200 meter per second. So what we are discussing here the truck being so heavy but with very little velocity, 5 meter per second, it may harm the person. It may kill the person coming in its path. On the other side, the bullet mass is very small and the velocity is too high. It may kill the person. It is certainly going to kill the person. Bring two quantities, mass and velocity relationship. Here also we are considering two quantities, mass and velocity. So the impact produced by the object depends on their mass and velocities. Here we are talking about bullet, here we are talking about truck. So the impact they are going to produce on an object, it depends on their mass and velocity both. And now here the term momentum is introduced when we relate both mass and velocity. Momentum is represented by P and it is the product of mass and velocity. So momentum P of an object is defined as the product of its mass and velocity. Here we have written P equal to mass into velocity. M is mass here and V is velocity here. So the SI unit of momentum becomes mass in kg, velocity in meter per second. So kg meter per second is the SI unit of the momentum. This is the SI unit. It has both magnitude and direction. So it's a vector quantity. Momentum is a vector quantity and the direction will be of the direction of velocity. Direction is same as that of velocity. So you have got the concept of momentum. Momentum is the product of mass and velocity, and you can explain it with the help of examples we have discussed earlier, that is truck and bullet. You can compare both of these, both of their mass and velocities. Truck being so heavy and less velocity, bullet has less mass and more velocity. So you can compare both of these for explaining momentum. These are very good examples for explaining the concept of momentum. So dear students, now you have understood the concept of momentum. Now we can easily discuss the second law of motion. You are easily able to understand second law of motion once you understood the concept of momentum. What is second law of motion? Let's understand this with the help of an example. There is a car with a dead battery. Dead battery means initial velocity u is 0. Car is not moving, the battery is dead, initial velocity is 0. And to start this car, speed of 1 meter per second is required to start the engine. How much speed is required? let's say speed of 1 meter per second is required to start the engine. So final velocity would be 1 meter per second in this particular case. Now how we can start this car, how we can bring it to the speed of 1 meter per second, how we can start the engine. Let's say one or two persons come and they suddenly push the car. That means they are applying the force. So it hardly starts initially. It doesn't start. But when these two persons continuously apply this force for some time, they are applying the force, they are pushing this car continuously for some time, then after some time, the car may attain the speed of 1 meter per second and the engine gets starts. So we can say that to change the momentum of the car from 0 to some value. Momentum means mass into velocity. Here velocity is this 0 and we multiply it with mass, we will get momentum. So initially the momentum is 0. To change this momentum to some value, force is continuously applied. Continuously applied means it is consuming some time also. That means we are talking about force which is applied for some time. So now we can relate the quantity momentum, force and time. We are about to obtain a beautiful relationship of force, time and momentum. Here initially the momentum was 0 and after some time, after application of some force, we have attained some momentum here, mass into velocity. We have got some value of momentum after starting the engine. So now we can state the second law of motion. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Here what we had discussed, that we are going to obtain a relationship of force, time and momentum in second law of motion. So how second law of motion is relating these three quantities? How it is relating? You can see here the rate of means whenever we take rate of something, we divide it by time. Change of momentum is final minus initial momentum and we are talking about its rate, so we will divide it by time. Is proportional to the applied unbalanced force. Here we will write force in the direction of force. We are talking about unbalanced force because the car has moved. Only the unbalanced force can bring a movement in the object. Here the car has moved, its engine has started. So we are talking about applied unbalanced force. If the force would be balanced, the car would have not moved at all. Here the car has moved, that means we are talking about unbalanced force. So can you see the relationship here? Force is equal to final minus initial momentum, that is the change of momentum, and we are talking about rate of change, so we have divided this quantity by time, is proportional to the applied unbalanced force. Here we have written force. So this is the second law of motion which we have explained on the basis of this example of car with a dead battery. Let's write the statement clearly. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So this is our statement of second law of motion. So dear students, I hope you have understood the concept of how to bring momentum in a car with a dead battery, and on the basis of that we have explained second law of motion. So if you have any query regarding that, you can mention it in the comment box. Now On the basis of the statement we have discussed, we can mathematically formulate the second law of motion. We can do the mathematical formulation of second law of motion. Let's discuss the mathematical formulation of second law of motion. For this mathematical formulation, we need to understand the second law of motion. We need to understand the statement of second law of motion. But before that, let's consider an object of mass m moving with initial velocity u, accelerated to final velocity v, accelerated by a, and force applied is F and time taken is T. We are applying the force on this object of mass m, and after application of force it has been accelerated to velocity, final velocity v. When the initial velocity is u, final is v, and the mass of the object is m, then initial momentum, let's say P1, is equal to mass into velocity, that is m into u, and final momentum will be, let's say P2, it will be mass into velocity m into v. Then change in momentum will be proportional to P2 minus P1, that is final minus initial. We can write it as P2 is mv minus mu. Take m common from this, v minus u, and this change in momentum is mv minus u. To make this value rate of change of momentum, I am writing here rate of change of momentum. We divide this quantity by time t. To make any quantity rate, we will divide this quantity by t. Now here you can relate this point with the statement of second law of motion. This statement is same as the statement of second law of motion. This equation, rate of change in momentum, is equal to this. This is nothing but our second law of motion. Second law of motion states that the rate of change of momentum of an object, this is rate of change of momentum of an object, is proportional to the applied unbalanced force. So now we are writing this as force proportional to rate of change of momentum. What we have written here, this is nothing but the statement of second law of motion, because we are doing the formulation of second law of motion. Now here in this expression, we have to remove this constant of proportionality. Here in this expression, I am removing this proportionality sign and I am writing it F equal to K into mass into acceleration, because this here is change in velocity. This is here rate of change of velocity, that is equal to A, that is acceleration. I have substituted this v minus u upon t as A because this is acceleration, and acceleration is rate of change of velocity. Final minus initial velocity upon time is our acceleration. So this is equation number, let's say this is equation number 1. Now for 1 unit of force, K constant, mass will be 1 kg and acceleration will be 1 meter per second square. From here we are getting the value of K, that is proportionality of constant, equal to 1. 1 unit of force, 1 kg mass and 1 meter per second square acceleration. We are getting the value of k is equal to 1. Now substitute this value of k equal to 1 here in this equation number 1. What we will get? We will get F equal to m into a, and that is nothing but the mathematical formulation of second law of motion. Here we have got a beautiful result which is relating force, mass and acceleration. We can easily use this relation in our numericals. Unit of force is m is kg, mass is in kg, and acceleration and unit of acceleration is meter per second square. So unit of force is kg meter per second square, and that is also known as Newton. We represent it by the symbol N. So dear students, I hope you have understood the mathematical formulation of second law of motion, and we have got the result force equal to mass into acceleration, and SI unit of force is kg meter per second square, that is Newton. If you have any query or doubt regarding this, you can mention it in the comment box. This is all for today. Thank you.